Charpy versus Izod impact testing explained why tensile strength alone isn't enough. Why do parts break suddenly? A customer complains that an automotive clip broke during installation. Another reports that an electrical enclosure cracks after a small drop. Surprisingly, both materials had acceptable tensile strength. So why did they fail? Because tensile testing measures resistance to slow loading, whereas real-life failures often occurs under sudden impact. That's why engineers rely on Charpy and Izod impact tests to evaluate a material's toughness. Strength versus toughness. Why impact testing exists? One of the biggest misconceptions is that a stronger material is always better. In reality, strength and toughness are different properties. Strength is the maximum stress a material can withstand, while toughness is the total energy it can absorb before fracture. A material may have high tensile strength but still fail catastrophically if it cannot absorb impact energy. Why is a notch introduced? Many people ask why we intentionally weaken the specimen by introducing a notch. The answer lies in fracture mechanics. Real engineering components really fail from smooth surfaces. Cracks usually initiate from screw holes, sharp corners, weld lines, molding defects or scratches, all of which act as stress concentrators. The standardized V-notch reproduces these conditions in a controlled and repeatable manner. Materials that lose significant impact strength because of a notch are called notch sensitive. Charpy versus Izod. Engineering difference. Although both tests use a pendulum, they simulate different loading conditions. In the Charpy test defined in ASTM D6110 and ISO 179, the specimen is supported horizontally like a simply supported beam and struck opposite the notch. In the Izod test, defined in ASTM D256 and ISO 180, the specimen is clamped vertically as a cantilever and impacted on the notch face. Engineers select the standard based on product design requirements and customer specifications, not because one test is universally better than the others. How is impact energy calculated? The pendulum starts with a known amount of potential energy. After fracturing the specimen, it continues to swing with reduced energy. The difference between initial and remaining energy is the energy absorbed by the specimen during fracture. Absorbed energy is equal to initial pendulum energy minus remaining energy. Depending on the standard, results are reported either as absorbed energy in joules or as impact strength in kilojoules per square meter after normalizing for the specimen's cross-sectional area at the notch. Engineering interpretation and common mistakes. Suppose your ABS material suddenly shows lower impact values than last month's production. Before blaming the material, check the notch quality, specimen dimension, conditioning temperature and test standard. Even a small change in notch geometry or testing below room temperature can significantly reduce impact energy. Remember, impact values are meaningful only when tested under standardized conditions. The goal isn't to break the sample, it's to understand how your product will behave before it fails in service. Understanding the result. Joules versus kilojoule per meter square. One of the most common mistakes is interpreting impact energy and impact strength as the same parameter. Impact energy reported in joules is the actual energy absorbed by that particular specimen before fracture. However, if two specimens have different dimensions, comparing only joules would be misleading. That's why most material specifications report impact strength in kilojoules per meter square. It normalizes the absorbed energy with respect to the cross-sectional area below the notch, allowing engineers to compare different materials on an equal basis. Impact strength is equal to energy absorbed divided by net cross-sectional area at the notch. Always check whether your customer specifications asks for impact energy or impact strength in kilojoules per meter square before comparing the results. For more such information, you can contact Presto. Thank you so much.